Hello there. In this video, we're going to talk about exponents, specifically fractional exponents. I have a bunch of examples for us today, but it's going to go pretty quickly. Most of them are pretty fast. So number one says, write an exponential form. This question says x to the fourth, and it's being raised to the third root. That little number means that we're taking not the square root, we're taking the cube root. You could rewrite questions in this form like this. The numerator is always the exponent attached to the inside number, and the denominator is always the indexed, the number inside the b of the root symbol. So this and this are equivalent. Number two wants us to go the other way, write in radical form. So we're going to write a radical. We're going to put an x. The numerator goes inside. The denominator goes outside. Now, if this is a 2, we don't have to write that. A square root has a secret 2 there. We don't have to write it if it's a 2. So because there's a 2 there, I don't have to write that. It's not wrong if you write it right there, but I'm not going to write it. And now it looks worse than it did. All right, find the value of k. Number 3. These two exponent problems are multiplying. And as long as they have the same base, you add exponents. So we just have to add 4/3 and 5/2. Now the short way to do this would just be to go on my calculator and just type in 4/3 plus 5/2. The long way to do it, the way that you probably should do it, is to get common denominator. So this would be 8 and 6, and this would be 15 and 6. So when you multiply these, you have the exponents, which would be x to the 23 over 6. So k would be 23 over 6. All right, so remember, when you multiply, you add exponents, as long as the bases are the same. And to get adding, to add, you have to have the exponents bases of the denominators be the same. All right, number 4 says find the value of k. Now we're dividing. Remember, when you divide, you subtract exponents. So we're going to subtract 9/2 minus this exponent that's not written here is a 1. But instead of writing 1, I'm going to write 2 over 2. That's equivalent to 1. And that would make things easier because now I can subtract the common denominators. So 9/2 minus 2/2 would be 7/2. So the answer to this is x to the 7/2. So k is equal to 7/2. All right, number 5 says find the value of k. When you're raising an exponent to another exponent, you multiply the exponents. And to multiply fractions, we just do top times top and bottom times bottom. So 2 times 3 is 6. 1 times 4 is 4. So x to the 6/4 is our answer. So k is equal to 6/4. And this one can't be reduced. This one can't be reduced. This one technically can be reduced. So let's make it 3 over 2. Just to be technical here. And the last example on the board here is number 6. It says select the equivalent expression. So when we're dividing, we subtract exponents. So I'm going to start by doing this problem inside here. -2 minus -8. -2 minus -8. And really -2 plus 8. So really inside of this whole square root sign, we have u to the 6th power, right? -2 plus 8 is 6. And there's still a 3 up here. So now if I go back to question number 1 and 2, so rewrite this without a radical symbol of being u to the 6 over 3, which is u to the 2nd, which is choice D. So those are our first 6 examples here. I'm going to pause for a second to give you some more examples. All right, next 4 examples here. Number 7 says find the value of n. So when you're given a question like this where you have some part of the problem with radicals, and some part of the problem without radicals, we want to get them all to have the same type. So let's make everything here not be a radical. Let's make everything here just have an exponent, a fractional exponent. So that means our numerator here will be x to the 4 minutes. This is the numerator, this is the denominator. And then our denominator here, let's use our laws of exponents here to multiply these two, because we're raising an exponent to another exponent. So that would be x to the 6/5. And conveniently, they both have the same denominator. Remember, when you divide, you subtract exponents. So 4/5 minus 6/5 would be x to the negative 2/5. So that means n is negative 2/5. All right, number 8, which expression is equivalent to this? So here's another new fact we need to talk about. When you have a negative exponent, you can drop the negative if you take what it's attached to and put it on the other side of the fraction. So what I'm saying is you can move this from the denominator to the numerator. You can flip which side of the fraction it's on if you drop the negative. So that's what we're going to do here. We're going to drop that negative, make it a positive 5/4, and then that whole thing that I circled moves to the top of the fraction. The 6 is not attached to this negative 5/4, so the 6 stays right where it is. So now we have x to the 5/4 over 6. Now that's none of the choices here, but you'll notice that this can be rewritten using a radical, using a 5 exponent and a 4 index. So that would be this choice here. All right, number 9 says find the value of n. Same thing as number 7. We have some that are radicals and some that aren't, so let's try to make them all not be radicals. We can simplify this by multiplying into power to a power, so that'll be x to the 5/6. And this one we just need to rewrite in exponential form. There's no exponent here, so that means there's secretly a 1, so that would be x to the 1/5. Remember, when you're multiplying, you add exponents. So we need to add 5, 6, and 1/5. So let's make them as common denominators. So that would be 25 over 30. And that would be 6 over 30. So those two add up to be x to the 31 over 30. So n equals 31 over 30 in this question. And then number 10 says simplify. Now this is pretty much just a calculator question. You can just go to your calculator. Your calculator will do exponential fractions as well. So I can just literally type this in as 49 raised to the 5/2 power. And when I hit enter, it will give me the answer, 16,807. But what does this question actually mean? This means 49 raised to the 5th and then square root it, right? So if you're not sure how to do that on your calculator, maybe you need to type this on your calculator. Or maybe you need to figure out another way to do this, like 49 square rooted, which is 7, and then raise it to the 5th power. Right, this full thing here, you'd see raised to the 5th power. So 7 to the 5th power must be 17 or 16,807, right? So when you're dealing with this fractional exponent, you can do it in any order you want. So I read this as let's square the 49, and then when we're done, raise it to the 5th power, which is what I did. So I already end up doing that question. The answer is 16,807. All right, last two examples for today. Simplify with only positive exponents. We have a very long expression. We want to simplify it, and it says only allow positive exponents. So we need to raise everything here to the negative 5/3 power. So we need to do 64 to the negative 5/3. We need to do x to the negative 18th to the negative 5/3. And we need to do y the negative 3rd to the negative 5/3. So you can see what I pretty much did is I took this, I don't want to call it distributing, but I made sure that everything inside the parenthesis got that negative 5/3. So this one, I could just do it on my calculator and hopefully get something that is a whole number. We did not get that whole number, so we simplify this. The negative, it said no negative, so let's start by doing that. Let's start by dropping the negative like that. Remember, if you want to drop the negative out of an exponent, you have to put the thing it's attached to on the other side of a fraction. So 64 on the other side of a fraction would be 1/64. And now I have that, I can do that part on the calculator. That works out to be 1024. Right? This one here, we have a power to a power, so we multiply the exponents. So negative 18 times negative 5/3. This is going to end up just being x to the 30th. Now, where would we put an x to the 30th of this question? We're going to put it on top. It doesn't have a negative, so it's going to go on top. And this one is also going to go on top because it's another negative times a negative. Remember, when you raise a power to a power, you multiply. So negative 3 times negative 5/3. That one works out to be 5. So this will be y to the 5th. That goes on top. So overall, this answer goes on top because it's positive. This answer goes on top, it's positive. And this one we already took care of it. It was negative, but we moved it to the bottom. So our final answer here is going to be x to the 30th, y to the 5th, all over 1024. And it's okay if you have some variation of that answer, but as long as you have an x to the 30th and a y to the 5th, your 124 can be down underneath, or your 1024 can be down underneath, or it can be like this. Excuse me. Make it so somebody looks like that. Same answer. All right, and the last question for today is number 12, expressed in simplest radical form. So just like this one, we're going to go like this. We're going to make sure everything in the parenthesis gets raised to the 5 as out. So we're going to do 9 to the 5s times x to the 5 to the 5 as. I guess just for consistency, I will put that in parentheses. All right, 9 to the 5/2. Let's check on our calculator, see if that works out to be a nice number. It does. It's 243. That must be 9 to the 5th power, and then square rooted works out to 243. Now this one, power to a power, multiply to 5/1 times 5/2. It's going to be times x to the 25/2. Now, this question is expressed in simplest radical form. So we're going to leave the 243 right here, and we're going to write this x as x to the 25th over 2, or the denominator of 2 goes out front, and the 25 goes underneath the radical. Looks like that. I would actually prefer this answer, but they said they want it in simplest radical form. So, all right, that's all for today. Thanks for watching. Have a good day.